Hello, Facebook family. Thank you for tuning in to Living a Text Life Volume 2, Microservices. I definitely appreciate all the support. All the love has definitely been much appreciated. This is your host, Rasheen. Wanted to just tap in today. I got a request from a friend of mine who mentioned that he would love to know a little bit about microservices and virtualization. So I think I'll put together this video. This is going to be a little bit more advanced than Volume 1, which, as we recap, went over installing Windows 10 and all the steps that was involved at a very, very basic level. Again, Volume 1 was more geared towards the beginner, the person who kind of wanted to see how things went on behind the scenes when it came to getting Windows 10 set up. Today is going to be definitely a little bit more advanced. This is a course that's geared towards the IT professional, the desktop engineer, the system engineer, DevOps engineer, even a developer. You can be a Java developer or Flash developer or whatever type of development you're doing. Today's Volume 2 is definitely going to be something that'll help all of you guys out if you haven't done virtualization or microservices. That being said, again, as I mentioned, Volume 1 was about installing Windows 10, which was done on a virtual environment. So again, for those that are watching this video who are not familiar with virtualization, the best way to kind of explain what virtualization is just think of it as, you have your computer, either your laptop or your desktop, and virtualization gives you the ability to actually run computers inside your computer. So I know people are saying, what do you mean run a computer inside your computer? It seems kind of weird. Why would you do that? Again, that type of technology has a lot of benefits, a lot of advantages, and the majority of it is for testing and development. So you're saying, okay, so you're able to do that. Like, how does that help development? So what it allows you to do is, having the ability to build something that functions right on your machine that can it can imitate something that's in the real world, allows you to modify things or find bugs, or allows you to really ramp it up and test it out for performance and that kind of stuff. The good thing about that is it allows you to test, allows you to do all these good things, record the output of what you're doing, and then destroy it. You can destroy it, you can tear it down, you get those findings, you make your changes, you create the environment again, and you get to kind of improve every time. Every single time you spin it up, you get to improve on it again and again and again. That there allows you to have faster output, produce faster updates, produce the best product possible, because you have that feedback loop of constantly being updated on the fly. So that's a little overview of what virtualization is. Microservices takes that same concept and just takes it to a whole nother level. Microservices, unlike virtualization, well, I should say similar to virtualization, does pretty much the same thing. The advantages of microservices is you don't have the overhead of a virtual environment. So I'll stop there and I'll go a little bit deeper into virtualization for the newbies out there. Those of you who are techie, I'm pretty sure this is boring information for you, but I'm going to kind of spill it out there anyway. Just as a recap. So when I built the Facebook virtual machine on my first volume, I built it on my virtual software that's on Mac called VirtualBox. Now, again, virtualization being cool, as you can see, I was able to run a demo from within a Mac to kind of show you exactly how Windows 10 is installed. Again, great way to do things. It has a lot of benefits, but it comes at a cost because virtualization has overhead. And what I mean by overhead is every time you build a virtual machine, it needs memory, it needs CPU, it needs hard drive space, it needs network, it needs whatever you need. Like, you need to put whatever into it that you need in order to demonstrate whatever you're trying to achieve. So again, great, works great. It's been working great for over 20 years. It has helped the IT business boom and thrive in ways that we've never seen before because of this technology. Now it's even improved better because with containers takes this concept and even makes it even more robust. And what I mean by that is, instead of the overhead of a complete virtual machine, where you have your memory and your kernel and all the other stuff, containers allows you to pretty much have everything you see here in one process. So instead of needing a set amount of memory or disk or whatever like that, you literally can have all of this running in one process. And what that allows you to do is allows you to run more. So, you know, let's say you have your machine and you're able to, let's say you can build 5 virtual machines, which is really good if you own a really good, powerful desktop or laptop. Well, with containers, you can run maybe 20. So as you can see, you can run more because you don't need as much overhead. So enough explanation and semantics. Again, everybody out there who's new to virtualization, I would definitely advise you all to give it a shot. VirtualBox is free for Mac. For Windows, of course, there's built-in Hyper-V. Or if you want to get a little bit more commercialized, there's always VMware, which is probably the #1 virtualization software in the world. I'm not sure if someone else may have taken over, but from what I remember, it was definitely #1. And I definitely advise you to take it, play around with it, get familiar with it, because it's pretty much where we are right now. And microservices is going to take it to a whole nother level. So I definitely advise you all to get in tune with that. So enough about virtualization. Let's get into containers and kind of explaining how containers work. So when you're dealing with containers, you have what's called the image, and you have the container itself. So all containers are created from container images. So I know you're saying, okay, what do you mean by container images? And what do you mean by containers? So a container image, just like those of you who are used to the virtual world, let's say you create a virtual machine and you take a snapshot and you want to store that snapshot as something you want to use as a start point for your virtual machine. Well, for the containers, you have what's called the container image. Works exactly the same as a virtual image, but again, without the overhead. So your container image will have your libraries, it'll have your binaries, and that's pretty much all you need in order to spin up the process itself, which is the container. So I'll give you some examples. I've downloaded a couple from the Docker Hub, and the Docker Hub is something that you all need to get familiarized with if you're going to do microservices. Docker Hub is public. It has just about any piece of software you can think of has a container image. The most popular, of course, is Apache, Nginx, MySQL. There's so many, a lot of these manufacturers are already making their own official Docker images for you to create containers out of. You can also create your own from a base Ubuntu, a base Red Hat, a base CentOS. All of the major distributors have created a base image for you to create container images out of. I'm not going to get too much into that because that definitely gets a little bit more advanced, when you're dealing with creating containers. I'm going to stick to strictly how containers work from a functional standpoint, and also how to create containers, not the images, but containers. So again, so far we've gone over containers, container images, and now the Docker Hub. When you install Docker on your Mac, your Windows, or your Linux, it automatically has a connectivity to the Docker Hub, which is the public repo for a lot of the official images. So that being said, we're in the Docker Hub, and let's do just a quick test to see what we can find out there. Again, we're going to stick with the idea of websites in this demo. So again, let's say we're looking to create a website. We need Apache. And, we just want to put some static pages up there. So we go to the Docker Hub. We find Apache's official HTTPD image repo. And as you can see, there's the cool thing about it is it allows you to have different versions. And I'm not going to get too much into why that's important, but for those of you who have done development, those of you who are doing DevOps, and even sysadmins, versions of different applications or different daemons or different services is very important, because a lot of code or even different types of libraries function with specific versions of servers or different versions of services or different versions of whatever. The cool thing about Docker is it allows you to have different versions of an image. So as you can see on Apache's repo, there's different versions that they created. There's Alpine that gives you the most lightest weight image that you can find. It has the latest, which is the latest and greatest release. You can even backtrack as far back as however far back they allow you to release. But again, this is important for those, let's say you are a developer who's been running this application for 5-6 years, and it's time to migrate now because either for security reasons or even just bug reasons, you need to move to a later version. What this allows you to do is it allows you to create an environment that mimics the current environment that you're using, so you can then start to build and develop into a later version. An example of this is I was working with Crooklyn Clan Network Scissorhands. We were working on getting his website off of a very, very old JNode version onto something newer. We're still working on that, but being able to have Docker create an environment that pretty much imitates his production to give to a developer to kind of develop on has been extremely helpful. Saves a lot of time. Again, allows you to perfect the application and just continue to build and restructure and all those good things. So enough of that. Let's actually see how it works. So a couple of things to note. The Docker pull. Well, actually, let's get into the Docker daemon itself. So when you install Docker on your machine, it gives you a Docker command, and there's a bunch of arguments you can use. Again, I advise you all to take your time and play around with the stuff, just for the sake of time. I don't want to make these videos too long, so I'll just kind of go over some basic stuff. On the Docker command, as you can see here on the Docker hub, you can pull the image down. So we're going to do a Docker pull, and I've already downloaded the image, so just for the sake of time, I didn't want to have it sit there and download the image and do all that stuff while we're sitting here. So when you run a Docker pull and you're pulling an image, again, it connects to the Docker hub, and it'll pull the image that you're specifying in your command. So it's Docker pull, and what are we pulling? The HTTPD image, which is Apache. One thing you'll notice when you run a pull command, it will always default to the latest. Now, this latest is what's called tagging. And again, tagging is how you differentiate the different versions of the image that you're communicating with to download. So just for the sake of our demo, we pulled the latest image of Apache from the Docker hub. So now that we have the image, let's go ahead and spin up a container. So we're going to run a Docker run. We're going to give it a name. We're going to call it Facebook Web, Facebook Apache actually, just to make it more granular. So we're gonna run a Docker run. We'll give it a name, Facebook Apache, and what's the name of our image? HTTPD. And here we have it. We just created a container. So let me open up a new tab because I'm gonna go through this really slowly so I can get a grasp of what's happening. So we pulled the image and we created a container. Great. So now you guys are wondering, okay, I see a bunch of text here on the screen. Okay, it looks like logging. You're absolutely correct. The container is built so that your output is the output of the actual error log of Apache, which is usually located in /var/log/apache/error.log. So now let's go open up another window just so you can actually see the process itself, because we didn't run it in daemon mode. We just ran it as a straight process so you can just get an idea. So what are we looking at here? So when you run a Docker run command, it does a few things. It creates a container ID. It gives you the name of the image that your container was created off of. This command is actually what the Docker, there's something called a Docker file that creates these images. I'm not going to get too much into it, but in your Docker file, there's a section where you actually have your command run as you're creating a container. I'm not going to get too much into that, but we'll just skim over it. This tells you how long your container's been running. This gives you the status of your container, tells you what port the container's running on, and this is the name we gave it. All right, so again, we just did a basic container run. We haven't mapped it to anything. I'm just giving you guys an idea of what a container looks like when you run it. So we're gonna go ahead and kill it. So now we killed it with a Control-C. We're gonna go back and see. As you can see, it exited. Why it exited? Because we didn't run it in daemon mode, which means we literally just ran it as a quick process. And there's a couple of things you have to do in order to get it to run in the background so you can interact with it and do other cool stuff with it. So now we're gonna go ahead and we're gonna remove that image that ran. So we're gonna do a Docker RM Facebook Apache. We check again that container's gone. Again, the image still exists. And again, we need to make sure we understand the difference between the Docker image and a Docker container. The image, again, is just like a virtual image. It is like pretty much like your start point of what you're going to build off of. You know, like when you run when you have a virtual image, that's kind of like your base image. You're going to start here and you're going to build on top of it. Containers, you can kind of look at the same thing when you're dealing with container images. It's your start point. And when you run a container, it actually references that image on how it's going to run the container. All right. So we have our container image. We just made sure that we were able to run a container successfully. It definitely ran with no problem. Now we're going to dive a little deeper. We're going to say Docker run. Going to give it a name again. We're going to call it again Facebook Apache. This time we're going to run it in daemon interactive mode, which means we're going to kind of run it in the background so it doesn't stay there and wait for us to interact with it. It's going to just run in the background. We're going to port it. Now, for those of you who understand computer porting, now we know that privileged users have access to port 0 to 1 to port 1023. Again, we're running these containers as a non-privileged user, so we want to make sure that we're allowed to open ports that we can access. So this -p command is a port argument. We're saying, okay, we want to port it, which means a forward. We're going to forward port 80 of the container to port 8080 of our machine. So now that we have this container, we have a Docker, we're going to run. What we're going to run, this container name, Facebook Apache, we're going to run it in daemon mode with interactiveness. We're going to port it to port 8080. And of course, what are we running? We're running the HTTPD image. Okay, so let's go and let's actually take a look at what's running. All right, so again, just as before, we showed that our container's running. Shows you the image name. Again, the command that runs from the Docker file. It's been running for about 7 seconds. Its status is up. And look at this, port parameter. So again, what we've done is we've said, okay, we're going to forward our local machine, port 8080, into the container's port 80, and our container name is Facebook Apache. So now let's open up a web browser and see if it worked. So we have the container running on localhost, port 8080. Let's see what we get. And just like that, we are successfully communicating with our container. Pretty cool stuff, huh? And just like that, again, I didn't need to build an OS. I didn't need to install a whole bunch of packages like that. It takes time. Again, if it's cool if you already have pre-packaged virtual images, of course, that works pretty well. But again, it's overhead. Container, usually those images are large. You know, you're talking, it may be close to a gig for a virtual image to run just to run a web server. In our case, if you do a Docker images, you can see Apache is just 132 megs. Very lightweight, right? This is our Docker image. 132 megabits compared to something that may be a gig or 2 gig in size. So as you can see, it's lightweight, gives you the same results. And even more importantly, you can build it up. You don't have to worry about networking. You don't have to worry about RAM and CPU. It's all right here in front of you in a matter of seconds. You see, I made this thing happen in literally 2 minutes, maybe even less than that. All right, so let's go ahead and tear that container down. Docker stop Facebook Apache. Whoops, sorry, typo. Take another look and see what our container status is. Okay, as you can see, we've stopped our container, it exited. Let's go ahead and remove it. Docker RM, Facebook Apache. All right, cool. Now that we understand how to pull an image, we know how to bring it up, we know how to interact with it as far as port forwarding, let's dive a little deeper into it and take a look at really what's happening here. So let's go ahead and run it again. Let's give it a name. We're going to call it Facebook Apache. We're not going to worry about all that porting and other stuff like that. We just want to make sure that it's running in the background. So we'll go and we'll definitely check the status. It's still up and running, which is great. No port forwarding because we're not looking to connect to it from a web browser. What we want to do is we actually want to interact with the container through a terminal session. This is the beauty of containers. So in that case, we're going to run a Docker execute. We're going to run terminal against Facebook Apache, and we're going to throw a shell at it. So as you can see, we went from my local folder into the actual container itself. And it takes us directly into the user local Apache folder. Now, again, the cool thing about this is the actual Apache environment. For those of you who are familiar with Apache, this is probably an Ubuntu version. This is why you see the path that it's sitting on the user local. Things like CentOS, Red Hat, you probably have a Apache. Apache, I think, is located in /etc/httpd. But I'm not going to get too much into that. But as you can see, all the libraries are here. His index file, his modules. You know, it's really, really cool. Again, all these libraries are located inside the container image, which is running just as a process as a container. So let's go ahead and exit out of here. Again, it seems like it's actually running on its own environment, but again, it's just a process, which is really, really cool. So let's go ahead and exit that. Let's go ahead and kill this. Docker stop Facebook Apache. Check the status again. As you can see, it exited. And let's go ahead and remove it. All right, great. So we've taken a look at a web server. We spun it up. We connected to it from the web browser. We connected to it from the terminal. Did a lot of cool stuff with it. You can also do this with databases. So let's go ahead and let's do a Docker pull. Again, just for the sake of time, I'm not going to show you the Docker Hub link. You know, you kind of get an idea of how it works. So we're going to Docker pull and MySQL version 5.7. This is going to lead into something else. I just wanted to give you guys an idea. So as you can see, I pulled the MySQL image version 5.7. I'm very specific with the version I want to use. And just as before, we're going to go ahead and we're going to spin this container up. Now, with the MySQL container, there's a couple of prerequisites to it. For instance, you have to specify your MySQL password. I'm also going to forward it to a port so we can communicate with it from our machine here. The MySQL port is 3306. And our name of the container is going to be Facebook DB. Let's go ahead and run it. We do a Docker PS. Whoops, sorry about that. As you can see, we have a container name. As you can see, we have a container ID, just as Apache. The image is very specific, which is MySQL 5.7. Again, when you see the command, this is the command that actually starts when you spin up the container. Spin up 6 seconds, and as you can see, it's forwarding to port. We have in port 3306, forwarded to 33060. And let's go ahead and connect to that container. Since I have my SQL client on my machine, I'm going to just run MySQL. Host is localhost. We have a port number, which is 33060. The user is root, and password is, I think we called it Facebook. Sorry about that. Oh, I know what the issue is. We need to make sure I got these commands right. Nevertheless, let's go ahead and interact with it through the terminal. Docker execute terminal. We have Facebook DB. We're going to interact with it from our bash terminal. Did I name it Facebook DB? Yes, I did. So execute Facebook DB, then bash. Oh, if I can just type correctly, I'll be fine. All right, so here we are. We're inside our MySQL database. And we're going to go ahead and log into it. And just like that, we have a MySQL server running as a container on our machine. Right out of the box, you have your information scheme, you have your performance schema, MySQL, and your sys. Let's create a database. Facebook. And just like that, use Facebook. And as you can see, really, really cool to have all this stuff running on your machine. I pretty much got this thing up and running in a matter of minutes. Instead of having to build a virtual machine, install packages, make sure I have everything set up. No, it was literally one command, got everything up and running. And this is how simple this stuff is. It's very, very powerful. So I'm going to go ahead and exit out. Going to go ahead and destroy our container. Let's first stop it. Facebook DB. Now let's go ahead and destroy it. Let's check it out. Status. And as you can see, we're from scratch. So as you can see, you can get really, really creative with this. You know, we have our web tier, we have our DB tier. If you wanted to add an application tier, you can do that. You can have it all running within your environment. So I'm going to end this off with a demo that I created just for the sake of this. But before I go to that, I wanted to actually show you guys. The cool thing about this as well is you can have your container interact with your machine directly, meaning you can have your container mount folders off your machine. So what I mean by that is, again, let's say you're a web developer and you have this content. You know, let's take database out of it for a second. We're just talking content at this point. You have an old application that's just a bunch of static web pages, and you just wanted to move it to something more up to date. Let's say you're running an old Apache 1.3 or an old Apache whatever, and you wanted to, let's say you just wanted to move from Apache to Nginx. You can just take that content and move it over to another web server. So that being said, let's go ahead and let's download Nginx. So I got the latest version of Nginx. And right here I have this is our test content. We're just going to call it, it's called Facebook Live. And we're going to create this web server and we're going to map our content into this web server, AKA container. So just like we've done before, we're going to do a Docker run, give it a name, Facebook Nginx. We're going to map it to our 8080 local host. We're going to do something a little different here. We're actually going to map our current directory. And I believe the folder for Nginx is user share Nginx, if I'm not mistaken. But we're going to give it a try anyway and see what we can get out of it. So what are we doing here at this moment? Just like we've done with Apache and MySQL, we're going to run our container off of the Nginx image. We've given it a name called Facebook Nginx. We're forwarding to our local host 8080. In this case, we're actually going to try to map it to our current directory so we can access our content directly through the container. I may have to check the path to the actual directory for Nginx. This may be why we're hanging here. So let's go to the Docker Hub just to confirm where the Nginx static folder is. So we'll go to Nginx, and that's it. It's user share Nginx HTML. So apologies, everyone. Let's see if we have any residue left over, because it did hang, and I believe it's because we had the incorrect path there. So let's go ahead and remove that container. Facebook Nginx. Let's make sure we're nice and clean. There we go. So let's rerun our command, and we're going to put the correct path this time. Make sure we have that accurate here. User share Nginx. Yep, that should be it. Let's go ahead and remove that image. Try to troubleshoot and see what's going on here. Nginx. Let's make sure that Docker's not acting a little weird on us. So let's just test this thing out. Okay, so we know we're good there. So what could be our issue? Just a quick troubleshooting session here. Let's go ahead and remove that. Docker remove Facebook Apache. Try to run Nginx again. Let me just paste the path this time. Make sure I don't mess this up at all. So again, we're going to do a Facebook run. Here's the name. Here's our port. Here's our folder that we're going to attempt to map. And this is our image, which is Nginx. Oh, you know what? I know why we're failing, folks. I did not run it in interactive. I did not run it in daemon mode. Nginx. So let's run it again. This time we're going to make sure we put the right parameters here. DIT, and there we go. So now we have our container running. Now, remember, we have content here, so we're going to actually test this out to make sure that we can get to our Facebook HTML page. And just like that, here we go. Living the text life. Pretty cool stuff, huh? Let's go ahead and bring that down. Let's stop Facebook Nginx. Let's go ahead and remove it. All right, pretty cool stuff. Now to end off the demo that we ran today, I want to take it a step further. I want to show you guys something called the Docker Compose. This is going to allow us to pretty much spin up a WordPress server, which is going to be a 2-container environment. We're looking at WordPress, which again, you can get off the Docker Hub. There's the environment variables for your database. And for MySQL, here's the parameters for that. And we're going to show you how powerful Docker can be. So let's go ahead and run Docker Compose. And we're going to spin up our environment. So what this is telling us is that we're going to spin up a WordPress microservice, which contains WordPress and a database. And it can be accessed through localhost 8080. So we ran that command, and we're going to go right to 8080, and let's take a look at what we got. Let's refresh that. There we go. And just like that, you have a WordPress container microservice up and running, and you can go ahead and configure it. Let's call it Facebook demo. Username is just going to be admin. Password is just going to be admin. We're going to use a weak password. We don't care about email. And we're going to go ahead and install WordPress. Oh, you do need an email. Right, so it's going to be demo at facebook.live. And just like that, we're up and running. Admin, I think we called it Facebook. Was it admin? And just like that, we have a WordPress environment up in our containerized environment. So I appreciate everyone for joining today. I hope somebody got something out of this. I think microservices, again, is the future. As you can see, we were able to spin up an entire WordPress environment in literally one command. And it works just like it would on a web server or in a virtual environment. Very lightweight. We didn't have to build an entire machine with CPU and RAM and everything else that came along with it. This is literally a process running. And if we actually look at the container status, as you can see, we have our two containers. One is the WordPress. The other one is MySQL. I hope you enjoyed Living a Text Life, Volume 2, Microservices. Again, this is Rasheen. Appreciate all the love out there. Apologies for having this pre-recorded, as Facebook Live was a little choppy today. So I'm going to go ahead and upload this, and I hope you enjoyed. Any questions, feel free to hit me up. And everybody takes care.